I will discuss the working principle of a Wheatstone bridge, which is used to measure an unknown resistance. So first let's discuss this simple circuit. There are two parallel branches and four resistances like this. Now let's say the voltage here is V1 and let's say the voltage here is V2. So V1, if we apply voltage divider rule, we know that the total voltage from here to here is V. So V1 will be V over R1 plus R2 times R2. That will be V1. And V2 will be, if we look at the other side, other branch, this one, V2 will be same, V divided by R3 plus R4, sum of the two resistances, times R4. Now, if V1 has to be equal to V2, what do we get? So V1 has to be V2. Let's assume a situation. So that will be V times R2 over R3 plus R1 plus R2, and here V of R3 plus R4 and times R4. So V gets cancelled and I can write this like this: R1 plus R2 divided by R2 plus equals to, that's equals to sign equals to R4 here, R3 plus R4. So if I divide, if I just write it as a fraction, so R1 over R2 plus 1 is equal to R3 over R4 plus 1. So these two 1 gets cancelled. We get a relation like this, R3 over R4, this one. So this is a relation we get. Now with this principle, let's see what a Wheatstone bridge looks like. So the arrangement is like this. It is drawn like this, but it's same thing, two parallel branches, and this is, let's say, R1 R2, this our same circuit basically, but this is how it's normally drawn. That's why I'm drawing like this. Now we have to, if we can achieve this situation where V1 and V2 is same, then we get this relation and and in this case, let's say we have one unknown resistance, one of them is unknown resistance. So we get, let's say R4 is unknown, so we have R1 over R2 is equal to R3 over R4. So this can be written R4 over R3 is equal to R2 over R1. So R4 will be R2. So if we know the remaining three, we get R4. So this is this thing. Sometimes it's written as Rx, but I am still doing 1 2 3 4. So like that. So how do we know in a circuit that these two points voltage are the same? So what can be done here? If a galvanometer is connected here, if these 2 points galvanometer is connected here, let's say, if these two nodes voltage are the same, then there won't be any current here because they are the same potential. But if they are different, there will be a deflection. So we can have a deflection in the galvanometer when there is these two potential V1 and V2, these two are not equal. But when they are equal, there won't be any deflection, and we know that this is same. Now what normally is done, one of the resistance, this one, let's say this one is made to be a variable resistance. So we have two fixed resistances there, one variable resistance, and this is our unknown resistance. So we have now R2, which is variable. So what is done, once we have this arrangement, we don't know, this is our unknown resistance. We know the value of R3, R1 and R3, and this one is a variable resistance. So what is done is, this resistance is varied until the deflection in the galvanometer is 0. When it is 0, there is no deflection. We know that we have achieved this equation. I mean this equality, this can be said to be equal, because before that it cannot be said to be equal. Once this is V1 is equal to V2, only then, because we have seen that we have found this relationship by equating V1 is equal to V2. Without that, this relationship doesn't hold. So we are trying to achieve in a Wheatstone bridge, what is tried to achieve is we try to get when V1 is equal to V2, and when it is they are the same at same potential, this node and this node, there won't be any deflection in the galvanometer, and this relationship will hold, this one and this one, so we can apply that relation. So basically that's what is done. R2 is varied until there is no deflection, and then we know this is the relationship. At that point we check the reading of R2 from the resistance setting, rheostat setting. So we have that resistance, that one is known, this one is known, this one is known, so we get the value of the unknown resistance. And this is how the unknown resistance. So if we change the unknown resistance now with some other resistance, then again we have to vary R2 until the galvanometer deflection is 0, and once it is 0 we can apply this formula to find the new unknown resistance. So this is the working principle of a Wheatstone bridge. It's very simple. So I probably will do one problem in one of the next videos.